Hello, everyone. Welcome to my session, Generative AI for Solution Architects. In our today's talk, we will talk about a lot of things actually regarding what has happened recently with OpenAI, Azure OpenAI. What are the new tools and platforms that they have launched? How can we use them? We will also talk about enterprise LLM lifecycle, LLM architecture, LLM ops, LLM issues, and LLM applications. So, as a solution architect, most things that you need to learn, we will try to cover most of the things here. And if anyone has any question, feel free to ask at the end, or even throughout the presentation. I'll be happy to answer. uh, about me, my name is 𝗷𝗲𝗃𝗂𝗁𝗁. I'm the Microsoft MVP in artificial intelligence from last 9 years. I'm based in Montreal, Canada, and for day-to-day job, I'm the head of data quality and analytics at International Air Transport Association, IATA. Okay. Um, it's been quite a few years. I mean, working in this data analytics and AI domain last 12 or plus years. And what I've noticed is recently with the chat GPT and GPT and LLM, huge amount of evaluation, new products, new services are coming, and everything started just a year ago. And it's crazy how those new products are being built. You can see within last 3 to 4 months, entire Azure ML, OpenAI, all those landscapes, the usage, the processes, the tools, everything has changed. New tool in prompt flow, model catalog, those were launched recently. And then how can you quickly create your own LLM model, fine tune it, use RAG. So all those new features are implemented. So we will talk about those mostly today. Okay. So, as a generative, what are the things as a we need to learn as a solution architect? So, if we look at the use cases for generative AI for a solution architect, these are the five key things I saw and I feel. First one is integrating Gen AI models in workflow automation. So, you can take Gen AI as your small army of workers or army of agents. So you can give them some sort of a dedicated work which is repetitive, and they know how to do it. They are fine tuned, retrained, or even they have the context prompt flow is there, so that they can repeat that process. Repeat the process in terms of preparing a chatbot, preparing a customer service agent, preparing a some sort of automation workflow, classifying text, classifying emotion, classifying different types of type of ask that your customer is asking through text or emails or something like that. So you can create this type of automation workflow as a solution architect, so that your life gets better. You can bring more automation into your day-to-day activities. Then to do those things, you need to understand the Gen AI lifecycle, how this process works from doing the development in a sandbox to putting the model into a production, how this end-to-end lifecycle looks like. So we will also talk about that one. So if you know the lifecycle, then you can help your developers, data scientists to build those models. Without knowing the lifecycle, it's completely impossible. Third thing is, third thing is understanding use cases. Where can you use generative AI? One thing you need to know that generative AI is not the only AI use case. There are so many other types of AI that we are using in our day-to-day activities, like different types of NLP, computer vision based, image processing based, video processing based, or even tabular based classification, regression, time series forecasting, unsupervised based clustering. So you need to understand exact use cases. Where can you use generative AI and where can you get the most out of it? There is a new term these days, LLM ops. You also need to understand this is the equivalent of ML ops. So we will also show some diagram about that one today. You also need to understand the limitations, where your Gen AI is going to fail, because just having a Gen AI, putting it into production doesn't mean it's going to make a lot of money and it's gonna be a big hit. No, you need to deal with the production. You need to deal with the different use cases that your AI will face into the wild. So one of the example is when ChatGPT was launched, everyone was so excited and it got a lot of hype. But when Google Bard was launched, you saw like there's so many like a negative sentiment. We noticed, oh, this didn't answer it well, it hallucinated. So those are the limitation you need to know. And how hallucination is a part of the Gen AI solution. So we need to know how can we control the hallucination. We will also like talk about that one. We will also talk like ways to improve the Gen AI model, because it's not going to be like that accurate. There is no deterministic answer. So if you have a like a Gen AI tool or LLM based like chatbot or some sort of like model, if you do use the same prompt engineering or prompt process, and if you ask the same question in different times, the chances are high that you may get two different answers, because it doesn't follow any deterministic answer. It's non-deterministic. In terms of that, you need to know how can you ground your LLM, how can you get the best result, how can you give the best context to your LLM so that it doesn't give like different answers at different times. Then using GenAI in a day-to-day activities. So how can you use it? What are the activities? What are the use cases? What are the applications? We will also like talk about that. What you can solve through GenAI and what you cannot solve through GenAI. You also need to know that. And the last one is prepare your own version of GPT model for documentation support or something. So this is something a solution architect is going to use in a like very often, because if you are designing large scale application or you have a lot of like components in your architecture, in that case you need to know how those network configurations are like connected with each other, how those subscriptions are handled, what are your organizational cloud best practices. If you have something, if you have the documentation, if you have the wiki, you can create your own chat GPT version, and in that case you can prepare one and share it with your other team members so that they can just follow it. So these are the like a 5 top use cases we see as a generative AI for a solution architect's use case. Uh, but now we will go in more detail, and we will go take each of those activities and then try to understand what are the limitations, what are the use case, how to do it, and everything. Okay. So the first thing I will do is we will look at the OpenAI playground in Azure. We will also look at model catalog, prompt flow review, and we will also like look at a quick RAG example so that we understand what we are going to talk about throughout this presentation. Okay, can you see my screen with the Azure portal?
Yes.
Yes, we can.
Okay, perfect. Because this is very important. Otherwise, yeah, we want you to follow the presentation and also like the demo as well. The demo is mostly to understand what are the new tools that has been launched and how, as a like solution architect, you are going to use them. So I have a question to everyone, all those people that are attending today's call. How many of you have built a chat GPT or GPT based application or fine tuned it or used prompt flow or used model catalog? You can say yes or no. Yeah. Or even you can even answer at in the chat. I did 1, 2.
No.
Okay. No, that's good. This is what I was expecting actually. So most of the people, what is happening, even including me, last few days I had to look at what is happening. How can I like what are the new tools that has been launched, and new tools are getting launched every single day. That is like literally crazy actually. So let's go to, if you haven't used like, as most of the people, only 2% said yes and everyone said no. So let's take a look. First thing, to use Azure OpenAI, what you need is your OpenAI instance. You need to create that within Azure portal, so or workspace. So what we can do is, first we are going to, this is our resource group. On that resource group, you can see already a lot of things are being created. But to create my own OpenAI, I'm gonna go click on create, and then just write Azure OpenAI. Azure OpenAI. Let's see what happened. See, this is the one, Azure OpenAI. This is what we will use. So this is our Azure service for OpenAI. If you click create, then it will take you to the detailed information about, oh, this is my subscription. This is the resource group I have chosen. This is the region. This is the name. I can select Gen AI demo workspace. And I can also select the pricing tier. In this case, for this specific subscription, it's a standard 0. And you can also see once you're satisfied with all the information, you can click next. But now the question is, you also need to be careful about the region, because one of the thing is OpenAI service is not available in all the regions. You can see Australia, Canada, US, France, Japan, Sweden, Switzerland, UK, and West Europe has OpenAI service, but Singapore or India or Japan, those data centers doesn't have the OpenAI services yet. So that's why you need to choose the like region which is close to you. So in that case, to me, I just chose it's US, and then I clicked. I'm keeping it open to all network. Then next, you can still add some tag if you want to like trace the cost and everything on an organization level. For this case, we don't need that. Then click next. Once everything is there, you will see a complete summary, and then you just like click create. It will be created right away. So we already have like OpenAI services created. So which is OP 2023. So this is the one I created last time. So once I create that one, exactly this page will emerge. So I can see the Open API kind, OpenAI, standard pricing, endpoint, and everything. So where is our important information? So the most important information is here, keys and endpoint. So you will need the key. You will also need the endpoint to use this OpenAI. But there is no model on that OpenAI. All those like GPT model, turbo model, text embedding model that we talk about are here. So we haven't deployed anything till now. So this is the first thing. Second thing, you also need to know about the price, how much it is costing. So if you click there, learn more under the pricing tier, you can see how much does it cost in different like currency, in different region. So you will get a complete idea. Okay, if you deploy Babbage 002, how much it's gonna cost you. Okay, perfect. Now let's go back and what will happen if you go to the model deployment section. So if we go there, it will create the Azure OpenAI Studio. It will take us there. So from the OpenAI Studio, you can see it just loaded that already 4 models are deployed. But if we want to deploy new model, so just click on create new deployment, select which model you want to have. Suppose GPT Turbo 16, the model version. I can select auto update to default, and then I can select Gen AI demo model 1. And then there are also like advanced version and everything. For now, I'll just like click on create. So you can see my Gen AI model 1 is deployed. So I can use this one. This is the deployment name. I will need this one to use this model with my chat version or anything. So it's that easy to use deploy any model. Now the question is, what does this tools looks like? So if you have a Azure account, and again, even if you don't, you can create one, get $200 free credit, and then I will suggest you to create a resource group, like create this Azure OpenAI workspace, and then go to this Azure OpenAI Studio. From there, you have a lot of other options, like you get a playground to chat. I will show some use cases here 5 minutes later. You can also see different types of use cases. Suppose the turbo chat or other types of like models that I have already deployed. I can select them. I can load an example. Suppose generate an email. So this is the type of email that I want. If I click, it will use GPT model to generate a complete email for me in this case. So something like that. The text that you see, this is what we call prompt engineering, where we are giving the context what we are looking for, what we are asking. So the context here is AI powered headphone that are priced this dollar, available at Best Buy, Target, and Amazon.com. So those are the information that we are giving to the model so that it can generate that email for me. So this is what we call prompt engineering, and that's why prompt engineering is important, because the GPT model has no idea what you're looking for. You're giving the context, the information that you are looking for, so that it can help you with all the email generation and writing. Other than that, you can also see the DALI, the image one, the all your deployed models, all the model information, their limitations and everything. You can have your data file, quota, and other content file as well. So this is how this OpenAI, like Azure OpenAI Studio looks like. Now, as we will show some more demos, so let's go to the like Azure machine learning platform. So we will come back to this Azure OpenAI Studio again. Okay. So now if we go back to our resource group, so let's click our resource group. In our case, we have a Azure ML like workspace, which is ML platform development. So that I have already created. If you don't know how to create an like machine learning workspace, it's pretty simple. So just like the way we have created the OpenAI, you just need to go to click on create, and then you just need to select machine learning or machine learning studio. So you can select Azure machine learning, and then you just like go through the process. But if you go back, so we already have one ML platform development. So this is my studio web URL. So this is the studio that we will go to. It also has certain other information here, the pricing, the networking and everything, so that you can take further. So if we go to the ML platform or Azure ML Studio, from here, it will take us this exact tool or web portal, which is Machine Learning Studio. So you can see there's so many other information here, like model catalog, authoring, asset, manage, and everything. So if I give it like a quick 1 minute overview, under the manage, your compute, like your machine, virtual machine, your monitoring is there. Under your asset, the data that you upload, the jobs that you're creating, the components, the pipeline, the environment, the Docker container, the model or artifact that you're generating, the model that you're deploying as an API, all of them are here under the asset. The custom machine learning like development process is under the authoring section. You can have your own notebook. You can run that notebook in your compute. You can use automated machine learning. You can use designer section. Plus, you also have prompt flow. So prompt flow is the one we will see a quick demo today, because the newest two tools that Microsoft has launched are prompt flow and model catalog. So now first let's take a look at the model catalog. So if you click here, you see there are already so many models. All of them are GPT based LLM models. So you can see Azure OpenAI language models, Meta Llama 2, and also like discover other model version and Hugging Face and everything. So Azure team has made a kind of like partnership with Meta and Hugging Face to bring their open source model into the Azure machine learning platform, so that you don't need to like do all those things manually. So if we just like search, suppose view models, you can have your own version of GPT models you can easily deploy, or suppose the 𝗵𝗵𝗁𝗂, you can click here and you can click on deploy as a Azure OpenAI model. Or if you want, you can deploy some other types of models. So suppose if we say emotion, we want to have an emotion detection model. So there are different types of like Hugging Face open source models are here. So you can click 𝗿𝗵𝗁𝗂𝗁𝗃𝗃. Okay, it's just a random model. All those informations are there. What is the, if you want to know more detail about this model, it will take you to Hugging Face page. Who has used it last 1 month? What is the detail of this training process? How it was trained, what type of tools it was used to train, and everything. So it is already trained. If you want to use it, you just deploy it. So how? You just click here and then click real-time endpoint deployment. Boom, it's done. So I have already deployed this exact model by clicking it here, because it takes 3 to 5 minutes. So I didn't want to waste that time. So once you click and deploy it, it will take you somewhere like this. It will show you under your endpoint, ML platform development. So if you click here, once the deployment is done, you can see exactly this model is deployed. Live traffic allocation is there. It is successfully provisioned, and all the other information is there. And even you can test your own like deployed model. If you click on test deployment, it will take you here. So what this model does, it just does emotion detection or emotion classification. So if you look at, there is an example, I like you, I love you. So this is a like example that they provided. So if we also like provide that one into our test endpoint, what happened? It ran and it says level 2. So like happiness or love is under the level 2 of the training data. That's why it has classified as a level 2. So if we say, okay, it was level 2, let's say something bad. I hate you. So what happened? So it says level 3, some sort of like a negative sentiment or something like that. Or I am sad, something like that. So you can see this model is already built in. It's already trained. It's already, you can just like deploy it in a couple of click, and you can even use it so easily. And you can even see how much you have consumed, how to connect this model with your Python code. Exactly, the sample codes are also there, or even C sharp. What are the like keys that you need to have to integrate it? What is the REST endpoint looks like? And then the monitoring. So how many times I have used it? You can see today I have used it a few times because of this testing. So every time I'm using it, it's showing me how many API calls we have received, what is the latency looks like. On an average, it's taking 63 milliseconds to prepare the response. So I can also see that one. Plus the logs is also there. So one of the interesting thing is, as a solution architect, you need to know how many options you have, how many base models you have, which base model is ideal for what type of use cases, so that you can take the base model and you plan your development on top of that base model. So that's why you need to, this model catalog is a very good opportunity for you to play with GPT based models, identify the limitations of different types of model, because one model is not useful for all the use cases. You can see some of them are good for text generation. Some of them are good for like a text to image, text classification, token classification, chat compilation. So you need to know what type of model you are going to use and what is your use case first, so that you can choose the right one. So that's the first thing I wanted to talk. Second thing is prompt flow. So what is prompt flow? As a solution architect, we have different types of workflow that we want to automate. So prompt flow gives us that opportunity, that platform, without writing tons of code, tons of orchestration by ourselves. We will use all the GPT based tools, the orchestration of LangChain and also like other tool bases, so that we don't need to do those things manually. So one of the example I can see, you can create standard flow or even chat flow or evaluation flow. You can bring your own data. You can prepare your own Q&A, web classification, chat with Wikipedia, all those use cases. So we will take one. So what is that one? Suppose we will take this web classification. Click on view, and then if you click clone, it will take you to the recreate that web classification. I have already created that one standard, so I'm just like going to show you. So web classification too. So what happened? We exactly see something like this. On the right pan, you can see like a complete graph of nodes, and on the left, you see something like that. So it looks very complicated and complex. So what does it mean? Before you use prompt flow, two things you need to do. First, you need to go to the like connections. You need to add your LLM or GPT model here. So in that case, go to connection, click on create. You can do add different types of connector, as your content safety, OpenAI, cognitive search, OpenAI normal one without the Azure OpenAI, and others. So if you click Azure OpenAI, as you already have created some sort of model, create a Gen AI model 2 example. Provided is Azure OpenAI. Subscription, you need to select, I believe, this one. And then all the Azure OpenAI accounts will be visible here. So this is my open of 2023, if you remember. And then I need to select the API key. I need to select the API base and API type and all the other information, so that I can connect that individual workspace with this prompt flow. In this case, I have already created. So you can see I've already created, the API base is provided, the Azure is provided, like information is already, API version is provided, resource ID is provided. So everything is set. So that's the first thing you need to do. So which means you need to create the OpenAI workspace first, and then you need to come here and do it. Third thing you need to do, second thing you need to do is you need to have a runtime. So I already have one runtime. So it is the VM where your workflow will run. So in that case, I have already used compute instance standard D4S, the number of count, and all the other information that you need to know. So if you don't have it, you will need that one to run your workflow. So I already have created. So this is like a second thing you need to look at. So now go back to web classification. So that, as I said, on the right side, you see the workflow. On the left side, you see the detail. So the first thing is, this will be a workflow that will do web classification. What does it mean? I can give a URL that my workflow or automation will take that URL. It will find out the content from URL. It will use some sort of like scrapper to convert HTML to like it's through some sort of HTML parser, get all the text regarding that one, and then it will apply summarize text. It is using GPT based like my own LLM like GPT based model. It is giving some sort of prompt that, hey, please summarize this following like information in text in one paragraph of 100 words. So it's going to summarize that text. And then it is also like given some sort of like example by the side. If the text type is this, it is categories app. If the text type is this, it is categories NFL or channel. If the text type is this, it is category of academia. If something else, it's none. So you can see it is already some samples are already given. And then what we are asking is we are doing a classification. So we are using those sample information to classify, to train first the LLM, and then based on the 100-word passage that we had, we have prepared this prompt to tell, hey, can you say this text is passage is about movies or apps or academic or channel or PDF or profile or something like that. And at the end, whatever result we get, we convert it into a dictionary, another Python code, and then we get the output at the end completely. Okay, so this is a like automation workflow. You can create your own automation workflow. All you need to do is provide that link, and then everything else will be a mix up of Python code, the prompt, engineering, and everything. So, and first you need to select the runtime that we have already done. And suppose this one, this is the URL of Azure portal. So what will happen if we run it? So let's click on run, and you will see it's running here. Done. So we have provided this URL. Then we get the fetch text content. So these are the exact text we have received from that URL, which is Microsoft Azure portal, blah, 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 blah information. And then we have summarized that passage into 100 words. So this is how the summarize looks like. And then we have provided the sample information to see how this classification looks like. And then we have given the prompt to, this is the prompt to do classify through LLM that, hey, tell me, is it channel, is it movie, is it app, that text we have selected. And our LLM has selected, it is a category app type. So, and then we got the result as a like convert to dictionary. That's cool. Now, what will happen if we provide something else, some movie? So suppose La La Land Wikipedia. So let's get this movie like link. So okay, so now go back. So my Azure URL was selected as a app. Now this is a movie link. Let's run the same thing and see what happens. So it should tell it's not app, it's movie or something else based on the flow that we have built. Okay, it's done. So you can see using that Python code, it has got the entire Wikipedia page. Nice. And then it's summarizing it into 100 words. That's also nice. And then using the sample values and then create using that prompt, it has does the classification and it has selected the category movie. So you can build this type of like workflow by yourself, and you can connect it with email, with the text, with the document, PDFs, or other types of like a documentation, so that you can apply this type of like automation workflows and make your day-to-day life better and faster as well, efficient as well. So this is another example of a new tool that Microsoft has launched, PromptFlow. So not only just the prompt flow, you can have bring your own data, you can have your own chat flow, you can even deploy those models, connect them with your web application, chats and everything. So you don't need to write those orchestration and everything. All those things are already there. Okay, so if we will go back to, so this was the second thing I wanted to show. And the third thing we will talk about is if you go back to this Azure OpenAI Studio. So let's come back. So you have your own data. So suppose we want to build a like a model for hockey. So what does it mean? So we want to have a Hockey for Dummies, we have a document that I have just downloaded. I want to build a chatbot where anyone can ask any question regarding hockey that are available in this document. So I want to create a chatbot on my own data. So how can I do that? So let's go back and see. So once you go to the chat section of Azure OpenAI Studio, you get this playground. From here, there is a new option as a preview, add your data. So let's click here and then add data source. In this case, I have selected upload file. The subscription, the blob storage I need to select. Here, I have already created a blob storage. And then you also need to select the cognitive search. So I have already created cognitive search account before. So you just need to create it first, get the IDs and everything, and then come here and select that cognitive search. Here, this is the cognitive search workspace that I have. Then you need to select an index name, where all those information will be stored. So Gen AI demo 3, suppose, add vector, and also so I need to select the embedding model. So this is in this case, this is the embedding model that I have already, embed 2. Okay, so let's select the embedding model, embed 2. I acknowledge and next. Now I need to select my own PDF file. So I have selected 2 PDFs, suppose Ice Hockey for Dummies, Ice Hockey for Basics. And then if I upload that one, okay, click next. Search type will be hybrid and vector. I acknowledge, next, save and close. So you can see some sort of work will happen by the site, and it's going to start to prepare. It's going to upload all those files. It's going to process those texts. It's going to create an a vector representation of those text of embeddings, and then store them in cognitive search, and then use them with your chat. So we will show 2 examples, what happened with these sample files and what will happen without the sample files. So it may take a few seconds. Okay, you can see almost it's done. We didn't choose that big of a data set, so it's pretty faster. So I haven't done any chat. I'm not providing any context. I haven't done anything. So, okay. On that document, there were different types of information like ice hockey offside rules, ice hockey, suppose if you go back, ice hockey basics. So you can see ice hockey offside rules, icing the puck, and all the other information are there. So we will ask something like that. So it's done. So now we can ask anything regarding ice hockey to our chat. So let's do that. Tell me about ice hockey offside rules. Offside rules. Operator must have at least one extension. Clear chat. I'm going to start it again. Playground setting. Search resource. That's weird. We go there. So if we go there, we can see all those 2 files that we have uploaded have already created some sort of semantic representation. So the extension that completions operation must have at least one extension. Gen AI model 1, new start session. Let's see. Let's remove that one and create again one more. And by the side, when we are going to search data source upload files, right, blob, test, index name is demo 45, embedding is embed this one, this. Right before this demo, I was playing with that one. If everything was completely fine, when you are showing something, that's the time it starts to break. Okay. So it will take few seconds. So what will happen? We will be able to do chat on that text. We will be able to do quick search on that document that we have just selected, this one, and even when we remove those values, it will even tell us, oh, I don't know because it doesn't have the context, so something like that. So let's try one more time, and then if it doesn't, we will show it in another time, or I will write a blog and then I will publish it so that you guys can follow that one later. And we also want to cover a lot of information in terms of how this LLM limitations, ways to improve our Gen AI tools and everything. Okay. Okay, this is actually done. We have already selected Gen AI model, suppose turbo chat. Tell me about 𝗁𝗁𝗃𝗃. Hmm. Setting structured. Parameter is sequence. Okay, so I'll actually create something as a, I'll check that one, what is the issue regarding the extension, but let's go back. So this is one of the way of creating the, using the GPT model to chat with your own data. Now let's take a look at how this works, how this RAG or retrieval augmented generation works. So this is the workflow that looks like. So you are providing your user question, then it goes into the LLM workflow. It takes your query, it takes your the question that you're providing, it query on the data. It uses cognitive search to query on the data, and it gets the search index. So this is a external provider of cognitive search. That's why it's outside of the LLM workflow. It sends it to the cognitive search, does the searching, get the search index, and fetch the information associated with that search, and then bring it and add it into the prompt, creates the prompt with the queried data and all the context that you're providing. Then you are querying to the large language model, where you are providing the prompt, you are providing the context, you are providing the data, and then LLM, based on all those information, prepares the response and then send the response to you. So this is how this end-to-end process looks like. And as LLM model is not trained on your data, it's always good to use your retrieval augmented generation, so that you can provide the sample PDFs, text, and other information, so that it's easier for LLM to search, fetch information, and give the context as well. Okay, so now let's take a look at how this architecture looks like. As a solution architect, you also need to see what are the types of processes you need to go through to create an LLM application. So this blog was published on GitHub actually recently. The architecture of today's LLM application. I really like that architecture, so that's why I have used it in this presentation. So this is how this workflow looks like. First, the end user send a query, or hey, this is what I'm looking for. Can you tell me about ice hockey or ice hockey offside rule? So you send it, use the UI to send your query. From the UI, there is a complete LLM workflow in the back. So there are two things happening. First thing is, from the UI, you copy the query and then add it into your initial prompt. By the side, you also take that query, convert it into embedding through embedded model. You have your own vector database. You do a search with the embedded queries with the vector database to find out all the other information associated with that query. Based on them, you also have a data filter if you want to do some sort of a filtering so that the unauthorized data are not copied or anything or fetched. And then you get the RAG related information. So something like this, you get extra information that your LLM needs in this case to complete your initial prompt. So you are bringing the query, and you are also bringing all the other associated information regarding that query. You're combining them with your prompt. You use prompt optimization tool to limit the prompt, to like keep the like number of token, give any kind of like a content like information that you are supposed to provide, or like any kind of optimization. And then you send them to the LLM API like OpenAI, like GPT model, GPT Turbo, or text and like or text Da Vinci, that kind. So your LLM used all the prompt information that you have provided, create the response of that right response of that query that your user have asked. And then you can also add some sort of content classifier. Is your LLM giving any bad information, any like negative information or something like that? You can have your content classifier to classify, is it a harmful response, offensive response or not. And based on that, once you're like completely satisfied with the response that you're getting from the LLM based on the context that you have provided, then you give it to the LLM output, which is shown into the UI, and user see that output that is prepared. So you can see on a chat GPT, we just see, oh, the UI, that's it. We ask something, we get something. But in the back, there's so many document search, in prompt creation, document filtering, LLM API calling, content classification, and then output preparation. So many other things are happening. And this is the like a modern architecture of LLM application looks like. Any question on this one so far? No? Okay, so let's move ahead. So for an enterprise level, to create an LLM like application, there is an enterprise LLM lifecycle. So this is proposed by Microsoft. So there are 4 different things are happening in terms of LLM. First one is like there are 4 loops actually: ideation and exploring, building and augmentation, operationalization, and managing. So all of them happens one by one. So once you have the business need, you do the ideation exploration phase. You create, okay, this is the project I want to build. This is the input, this is the output. And then you go into the project development phase of build and augmentation. Then you build your model, you do a lot of fine tuning and everything. You prepare, once you're satisfied, you deploy it. And then after the deployment, you need to like have feedback to see if this model is doing good or not. Sometimes you need to like go back and change a different like a fine tune your requirements, change different different types of like databases as well as a rack. And then the entire process of managing this is also like a loop that we need to like follow. So this is the enterprise lifecycle looks like. So if you go a bit detail, how does it looks like? So the first one is, and what are the tasks we do? First one is ideation and exploring loop. So you need to understand the business requirements. You need to using use case specific foundational model. As I said, not all models are applied for all use cases. You need to find out this foundational model is good for text classification or summarization or chat or Q&A or something like that. You also need to then create some sort of prepare some sort of data. You need to create the prompt. You need to identify limitation. Oh, you don't have data, you don't have samples. So that kind. So this is the first part of like enterprise LLM lifecycle: ideation and exploration and selecting the foundational model. Once you have the foundational model, once you have the initial data and the prompt, then you go into the building and augmenting loop, where you guide the LLM to meet specific needs. You train your base model on your local data on or even real-time data. So what does it mean by local data and real-time data? You can use a RAG-based process to connect your LLM with the SQL or non-SQL data injection, so that the prompt is complete and it has more context similar to this. So this here we have searched VectorDB to get more context. You can even have like SQL search, non-SQL search, SQL queries, that type of like extra data injection tool as well, so that your prompt has more information. Then you can also do fine tuning of your LLM, exactly how you want your LLM to answer. So this is what you can teach your LLM here. And then you can combine RAG, fine tuning together to get the optimal outcome, an optimal result of your LLM GPT bot. Then the third one, once you are satisfied with the way your bot is performing, then you go into development to production. You need to deploy that model. You need to monitor that model. You need to incorporate content safety and other kind of like CI/CD process, so that as your LLM is creating content, you always want them to like doesn't you want them to create any harmful content or negative content. You can like control those based on using content safety as your services. Then you can also use Azure AI prompt flow for the deployment. It's very easy to use as well. Once you deploy that one, when people are using it in production, you also want to collect those queries and responses for monitoring, so that you can identify, okay, that many people are using it every hour. You need to have that many instances into the production. What is the cost estimation looks like? Do you need a different model to make it cheaper? So you need to have that type of like operational loop here. And then once your model is in production for 6 months, 1 year, or even to couple of months, you can detect the drift. So what type of responses your model is not giving well, what type, where it's lagging the most, where the quality is degrading, so that you can fine tune it again. You can do RAG integration again, this kind. You can also like give more context. You can do more prompt engineering. And the last one is enterprise lifecycle. You need to have follow proper tooling, governance, management, security, following responsible AI principles. So these are the like four things of enterprise LLM lifecycle: ideation, building, then the operational loop of your deployment, and the managing LLM or managing loop of through governance, management, and security. So it's not super straightforward that have a GPT model, deploy it, and done. No, you need to follow this entire process. Now, the second thing is I want to talk about next is LLM ops. So we have heard about ML ops, but what is LLM ops? So this is a new word that recently emerged. Large language model ops it's the process and techniques and tools of operationalizing a model, managing a large language model, retraining a model, deploying a model. So that entire life cycle is LLM ops. Just like the way we have ML ops, it's a similar to LLM ops. So now let's take a look. What are the differences? For MLOps, so that's how it looks like. You prepare the data, which is registering data source, data transformation, data wrangling. Then you build and train your model. It can be a classification model, regression model. You do feature engineering, model and algorithm selection. You train the model, test the model, do the hyperparameter tuning, and then you deploy. On the deployment, you validate the model. You package the model into a Docker container API. You deploy it. You deploy it as an inferencing API, and also all those production inferencing you're making, you also use them as a store them in a production data store. And the last thing is monitoring the data drift, monitoring health of the model, infrastructure monitoring, A/B testing in future for any kind of like retrained model or something like that. And once you are not satisfied with the model result, you go back and retrain it from here. So this is the regular day-to-day traditional machine learning lifecycle looks like. Now, if you look at LLM ops, how does it looks like? So most of the things are same, just the changes are here in this build and train section. So in terms of LLM ops as well, you register the data set, you transform the data, you do some data wrangling, you keep things side by side so that you can fine tune your model, your data sources ready to test your model. Okay, so this is the data prep. Under the build and train, here you don't do feature engineering and model and algorithm development and retraining training from scratch. What you do is you do the base model selection first, you do the prompt engineering, you do the fine tuning, how you want the result to be, you do the RAG, retrieval augmented generation, which means you give more text, PDF, different sources of context to the model, you do hyperparameter tuning, and then you repeat that process until you get the best result. After build and train, once you're satisfied with the model, you deploy it, validate the model, package the model, deploy the model, inference the API and production data source as well. And the last thing is you will still need to like detect the drift. In what type of scenarios your model is not performing well, where your model health is not doing well, where it's taking a lot of time to respond. Do you need to change the infrastructure, have bigger VMs to accelerate the inferencing process? If you have two types of model, testing the A/B testing and then retraining. So Under LLM ops, everything is same, just the process is different in build and train, but LLM and ML ops, all of them are mostly follow the same framework. So why do we need LLM ops? Why don't just like train the model once and then done? No. So you need to follow the LLM ops life cycle so that you can build efficient, like bring efficiency. You can build your model fast. You can also like deploy it fast as well. You can have a scalability. In this case, instead of having a single pod of your deployed model, you can have scalable, like multiple pods, so that hundreds of people can use it at the same time to your model, and it's automatically scalable. And you also need to have risk reduction. You can add regulation so that your model doesn't give any bad information. You can add monitoring and drifting so that you understand where your model is lagging. And you can also have a transparency. If your model is saying something, what is the data source of that result or information? So to incorporate all those best practices, efficiency, scalability, and risk reduction, you need to follow the LLM like lifecycle or LLM ops. And as I have already said, LLM's components are exploratory data analysis, which is a part of the data processing. And once you get the data, prepare the data, identify the data, prepare the data as well, you do the prompt engineering. You do a lot of testing with the prompt engineering to get the most context to your model. You fine tune your model, introduce RAG, and also like you review the model at the governance, inferencing, serving, and also like monitoring. Okay. Now, how can you make your model smarter? How can you make your model better? So there are three key ways to make your model better. First one is prompting, giving more textual context to the model. Second one is fine tuning, bringing more data, sample information, and retrain your model with that. Third one is RAG, retrieval augmented generation, which is giving more data sources, live information to your model, prompting, fine tuning, and RAG. So if you look at how can you make your LLM smarter, those three options that we talked about, prompt, fine tune, and RAG. So when you train a model, your model needs to have certain outside information, plus your model needs to have some domain information. So that domain knowledge is provided, but outside knowledge it comes with. So if you do just prompting, just give some textual information. In that case, you are giving that domain knowledge on the prompt, and your model also have very little outside information because the model was trained 3 months ago, 4 months ago on generic information. That's all it knows. So its knowledge is low level. But if you do the RAG on domain knowledge, but you also bring RAG on outside information, which is PDFs, text, or other types of JSON types of information that you provide, then that is good. In that case, your model has more domain information, more outside information to prepare the answer or something like that. If you just fine tune it, retrain it with some extra data so that it understand how to answer it, how to organize the output. Are you expecting JSON based response or some other types of response? So through that fine tune, it will have domain knowledge, but it will not have outside knowledge because you're not retraining it based on outside knowledge. But if you do both fine tuning, prompting, or even like RAG, all of them combined, then your model will have a lot of domain knowledge. Your model will have a lot of outside knowledge. So this is one of the best ways to make your model smarter. And if you look at the reason why fine tune, prompting, and RAG is the best, applying all three, it will have access to current information through RAG and fine tuning because you're using updated information to retrain how you want the response to be, and also giving the model all the new context. You also providing specific information through RAG. You're also controlling the hallucination by giving the context so that it doesn't create its own response by itself. And whatever the response the model is giving, you can show to the user that, hey, this response is coming from this PDF source, so that it's more trustworthy and it's also traceable. So this is one of the a key way of making your LLM model smarter in this case. So we also notice certain issues in terms of LLM. First one is misinformation. Like our LLM model can easily give a wrong or biased answer. So when we don't provide enough prompt engineering text or context, it doesn't have sufficient information and it can easily give biased answers. And this under hallucination, we see two types of hallucination. One is intrinsic hallucination. Second one is extrinsic hallucination. So it can combine two types of data, information, or sources and create some sort of fabricated content, which we call intrinsic. Or when it was trained, it has trained from a unverified source or like irrelevant information from the online. So it can give extrinsic hallucination. It looks like, oh, it's a bad information that it has given, but the way it was trained on the training data, maybe that information was unverified from an unverified source. It just like collected that and it just responded with that. So we need to like deal with both the cases: fabricated content, which is created from multiple sources, and unverified sources or unverified content provided during the training like situation. Hallucination can be reduced by increasing training data, kind of like doing more fine tuning and involving more contextual references through RAG, PDFs, and all the other information, so that it doesn't go outside of the like scope. And as I have already said, LLMs are non-deterministic. Same prompt may prompt at different times can give different answers. So we need to be careful regarding that. Now the question is, what can you do with the LLM and what you cannot do? So LLM is great for summarizing information. If you provide the information, it can summarize it. If you, it can also like perform better with an augmented context. When you give the text, give the sample information, it really perform well. It can be a great coding assistant. It already has a lot of examples like Google GitHub Copilot or something like that. It can be supported by other software processes like when we use ChatGPT, it's not just using, you are not using the raw LLM model. It is in the backend, just like the way I have showed in the like architecture. It has different types of like vector database. It has other API. It has other SQL and non-SQL connections, so that this GPT response has more context and it gives you more like real information. So we also like need to know that if we use LLM in our own application, we need to, in the backend, we need to give more context, more API, more like PDFs, more text, so that it gives the right information. So it can be supported by other software processes as well. And things it can also do is it can be a great source to augment your own knowledge base to users. So as I said, if you have a web application or a mobile app, you can easily use your own documentation, manuals, user policies, and everything, and build your own GPT model and expose it to your user base, and they can easily search, oh, what are the limitation, how to configure this one, that type of information to build your own ChatGPT kind of model. But what Gen AI cannot do, first thing is it cannot be certain about something. It has a hallucination problem. It will answer you, but if the training was wrong, if prompting was not right, it can give you bad result. So you need to be careful about that. It cannot figure out new things on its own. So it doesn't know like new information. So you need to provide that information through RAG or fine tuning or through other ways. So you need to provide that options. It cannot be certain if another content was created by Gen AI or another GPT model. So it has no idea. So you cannot use the GPT to tell, hey, can you tell me this passage was written by another GPT model or not? It cannot do that. It cannot properly cite the information by itself, because when it was trained on bulk text. So it learned the weights, bias, like matrices, but it didn't learn the sites or sources of those information, and it can easily hallucinate the source like from the training. So if you ask GPT some question and it answers, and if you ask it, do you know the source of this information? It will just tell you, oh, it was provided during my training process. So it doesn't know where this knowledge comes from. So you need to be careful to use those information. And one of the big question that we get is GenAI can take your job or not. Honestly, it cannot. But again, it has no way to proactively learn for itself. But we can use GenAI to automate a lot of things and automate a lot of like a manual job and processes. So this is the scary part. But GenAI by itself, no, it cannot take your job or anyone by in any way. So LLM applications, where can we use LLM? For writing assistance, for sure. Technical, creative writing, general editing, documentation, or programming sample support, we can use them. Information retrieval, we have seen that Bing is using search engine support, like a GPT for search engine support. Conversational recommendation, so many applications are there these days. All those like mobile apps are adding like GPT-based conversational recommendation, or like document search as well. Document summarization, text interpretation are other use cases. For commercial use case, we can see customer support. It's the one of the most one. Machine translation, automation of workflow, the one I just showed under using prompt flow. Business management and medical diagnosis. If you have a telemedicine system, you can see a lot of companies are trying to come up with the GPT-based telemedicine chat application as a screening tool. And for individual use cases, you can use GPT-based models for productivity support, Q&A, brainstorming, educational purposes, and problem solving. You can have a GPT-based assistant to discuss, to talk, and everything. So those are the use cases that we see as a solution architect. But I have also like talked about the limitation, how can you make it better, how the architecture looks like, and some quick demos on the GPT. And again, my main message will be, don't forget, Gen AI is not the only AI. So it's just a part of the AI. So there are also like NLP, computer vision, other types of AI like classification, like regression, forecasting, all of them are there. So don't just focus on this, focus on the entire suite of AI systems. So that will always be useful for you. That's it of my 1 hour presentation. Thank you so much. You can connect with me on LinkedIn following this link.